Hello, everyone. This is Rio Umagami from the University of Tokyo. Today, I will be presenting our NeurIPS 2025 paper, Intend to Move, a multimodal dataset for intention-aware human motion understanding. Let's begin by looking at this scene. We see two people interacting in a home environment. Their movements are not random. They are inherently intentional. But what are their specific goals? Will they study, get a drink, watch TV? We don't know. This is the challenge. Future motion depends entirely on their intention. This leads to our core problem. We can analyze what is happening, the low-level motion. For example, a person is standing up, but this ignores the why, the intention. Why did they stand up? To get a drink, leave the room, or just stretch? The what doesn't tell us. Most models focus only on the what, capturing short actions in sterile lab environments. They lack the why, the intention. This disconnect between what and why is the gap we aim to bridge. To bridge this gap, we introduce Intend to Move, a large-scale 10.1-hour dataset of complex two-person interactions in realistic home environments. We captured multiple modalities: A. 3D human motion, B. Multi-view RGBD video, C. Instance-labeled 3D point clouds and meshes, and most importantly, D. Time-stamped intention annotations. Our core contribution is this intention annotation. We shifted the focus from describing the action to understanding its motivation. Previous datasets label the what. A person walks to the fridge, takes out a drink, and drinks it. In contrast, we provide the why. The person is thirsty. We defined 4 categories of intention: long-term activities, like studying; short-term needs, like drinking; environmental responses, like answering a phone; and social intentions, like collaborating. Crucially, this intention annotation is time-stamped and synchronized with the motion and video data. Here is a visualization of a sample sequence from our dataset. To distinguish the interacting partners, we render the human meshes in different colors. The person shown in pink starts by relaxing on the sofa, but then stands up to fetch an item from the table. Meanwhile, the person in blue is attending an online meeting and later gets up to retrieve something from the fridge. This example demonstrates how our dataset captures complex, multi-person interactions within a dynamic home environment. We established a benchmark task: predict 5 seconds of future motion from 3 seconds of past motion. We extended the Afford Motion framework to support a diverse set of conditioning inputs. Specifically, our model incorporates intention text, RGB images, past root joint trajectory, and motion clip feature to guide the generation process. We evaluated the performance using standard accuracy and diversity metrics. Our benchmarks revealed a semantic gap between high-level intention and low-level motion. We found low-level trajectory cues gave the highest accuracy. Conversely, high-level cues like intention text or RGB images performed poorly. This shows models are good at extrapolating motion, but fail to translate high-level semantic goals like intention into coherent motion. Now, let's look at the qualitative results with intention text input, which show some promising successes. A. For receive an item, the model correctly predicts the agent's motion, walking toward and extending an arm to accept an object from their partner. B. For want to take out the bento, it generates a plausible walk from the sofa to the fridge. However, we also observed significant failures in physical plausibility. A. For clean the room, the model generates impossible motion, penetrating the bookshelf and floating. This reinforces the semantic gap. Models struggle to translate high-level goals into coherent motion. It also highlights the challenge of generating scene-aware, plausible motion. In conclusion, we introduced Intend to Move, a large-scale dataset to shift motion research from what to why. Our benchmarks revealed a semantic gap. models struggle to ground high-level intentions into low-level motion. This points to two future directions. First, new models to align semantic goals with motion. Second, new evaluation metrics to measure intention fulfillment, not just geometric error. We believe our intend-to-move dataset will be a crucial resource in driving these future directions. You can find our dataset, code, and paper on our project page. Thank you very much for watching.